Welcome to another exercise in the workbook statistics. This time talking about an exercise focusing on the so-called goodness of fit test. Let's have a look at the exercise. Here we have, in the last half year, a social media platform registered the following numbers of new members. And we have for 6 months the different membership numbers. Our task now: test whether the assumption about the distribution holds that the number of new members doubles with each new additional month. Assume an acceptable margin of error of 5%. Well, in this case we have actual absolute numbers on the one hand, and we should check whether these numbers follow a given distribution. That's more or less the information here. The new member numbers should double each month. Well, with this information, this is a clear indicator that we are going to use the so-called chi-square goodness of fit test. How are we going to go about this? Well, we first copy the table as is and then determine the probability or the distribution we want to have and the respective probabilities. So that's more or less the expected relative frequencies we want to assure. Here, well, we first have to decide what do we actually have here. We can do this in the following way. Here, if we start with 1, this would be 2, 4, 8, 16, and 32. Then we could add all of this up and divide the numbers by this. So this is 1 divided by the sum, 2 divided by the sum, 4 divided by the sum, and so forth. So those numbers might look strange at the first glance, but they're actually relatively straightforward to be calculated. That's actually the distribution we want to check for in these data points. Well, for this we also need the overall sum of observations, the overall sum of members across the different months, because then we're going to multiply each of these different probabilities with the overall sum. Once we did this, we get these numbers here. That's the expected absolute frequencies. So that's the values we would get if the numbers were to be doubling each month. So that's the ideal numbers of members if this distribution were to be holding with those overall number of observations. So that's more or less all the preparatory work we have to do, because then we can start with the real chi-square test, as in first of calculating the chi-square statistic, the test statistic, by simply applying the chi-square formula to each of the 6 different months. Meaning we're going to take the actual frequency, so the 110, we're going to subtract the expected absolute frequency, that's this one, and from this difference we're going to take the square. The square then is divided by the expected frequency. And this is something we're going to do for all of our 6 different points or 6 different months. So in the second one, we have an actual frequency of 255, an expected of 241.4. So it's actual minus expected divided by expected. Here as well, actual minus expected divided by expected. Maybe at some point you've seen a slightly different formula where in the upper part, here in the brackets, the actual and the expected frequencies are the other way around. However, this doesn't matter since we square the result. So the end result will be exactly the same. So it doesn't matter if up here they are the other way around, but you have to take care down here, it needs to be the expected frequency. Well, once we have this, we can put all of this into our calculator, giving us as a final result a value of 5.3844. So that's our test statistic. That's the value we need to conduct our test. And that's the value we're going to compare with a reference statistic. So that's actually the next step we're going to do, calculating the respective reference value or statistic. For the goodness of fit test, the reference statistic can be determined as follows. That's chi squared, I minus 1, 1 minus alpha. The I, that's the number of different, well, groups, characteristics, whatever. For us, it's the number of months. So here we have 6 months. So I is 6. 6 minus 1 gives us 5. And we have 1 minus alpha. Alpha, that's the expected or allowed margin of error. Here we said in the exercise text 5%. So we're going to calculate 1 minus 0.05, giving us a value of 0.95. So we turn to the table for the chi squared distribution and look up the value chi squared 5, 0.95. There we're going to find a value of 11.07. So that's the value we're going to compare our test value, our test statistic we determined on the previous slide with. That's the test decision. So we take a look, test statistic, reference statistic, and we see that the test statistic is definitely smaller than the reference statistic. This is always an indicator that we cannot reject our H0 hypothesis. And in the context of the goodness of fit test, the zero hypothesis means that the actual distribution follows the given distribution. So the actual values, the actual frequencies follow the given distribution. So in this case, we can say that the actual membership numbers follow the expected, well, idea, followed the quote from the founder, or if we turn the slide here around, do not significantly deviate from the expected, assumption of the founder. Well, that's then everything there is to this exercise. I hope you enjoyed it. I say goodbye and see you next time.